So AD, micro anaerobic digestion, can be applied to anywhere there is a need and benefit for anaerobic digestion, but a full-sized system won't be appropriate because of cost and footprint constraints. It is generally anticipated that micro-scale biogas plants are on farm installations using only own waste biomass resources, where livestock manure is a main source. Micro-scale digestion involves the production of biogas, but on a small scale within the farms. The small-scale digestion production units are below 80 kW. Co-digestion is the simultaneous digestion of a homogeneous mixture of two or more substrates. Traditionally, anaerobic digestion was a single substrate, single-purpose treatment. The most common situation is when a major amount of a main basic substrate, example manure or sewage sludge, is mixed and digested together with minor amounts of single or variety of additional substrate. The use of co-substrates usually improves the biogas yields from anaerobic digester due to positive synergisms established in the digestion medium and the supply of missing nutrients by the co-substrates. This is the report we have generated last few weeks. So this is the first one is the anaerobic two-stage anaerobic system. This is MTR. This is ACR. The left one is ACR. The right one is MTR. The left one acetogenic reactor. Right one is methanogenic reactor. We have also daily we have measured the gas volume as well as pH, temperature, and then we can note it down the gas measurement in the note. So what are the analysis methods? So all water quality parameters we have analyzed. Example TS, VS, TV, FA, TCOD, SCOD, TKN, TAN, TP, TOC, VOC, VSS were analyzed according to standard method EPHA 2005. So composition of biogas was analyzed using the gas chromatography method. Here we can see some pictures. UV, TOC, total organic carbon, GC, distillation unit, then Kell register. So biomethane potential test is another important test to evaluate the potential methane gas production. So the BMP test we evaluate the potential of specific substances to be used as substrate for methane gas production. We are currently aim to evaluate BMP value for three substrates and their mixture with ratio 2:2:1. The test was provided under mesophilic condition with initial pH of 7.55 for all samples. Here you can see the picture BMP test schematic diagram. The water bath, the septum mixer, then the gas CH4 and CO2 is coming to the inverse solution. After passing through the solution, it will come only methane. Then it will detect on the sensor. We can monitor the pure production of methane gas. So what are the conditions we have to set the BMP? It's very important. BMP test require a blank, control and substrate. All groups should be performed in triplicate for reproducibility of the test and statistical analysis. The substrate bottle is filled with inoculum, the substrate and added nutrients if needed. The blank is filled with inoculum, a medium or water, but no substrate to provide the background methane generation from the organic material in the inoculum. The control assess the accuracy of the BMP test using a substrate with a known theoretical methane yield. So what environment should be needed for BMP means a temperature controlled environment, proper mixing, sufficient incubation time for the degradation of biodegradable material. So temperature, most anaerobic digesters are operated in either mesophilic or thermophilic. Mesophilic 32-38 degrees Celsius, thermophilic 52-58 degrees Celsius temperature ranges. Thermophilic digestion is faster than mesophilic digestion since the biochemical reaction rates increases with increasing temperature. Additional advantages are increased solid retention, improved dewatering, and increased destruction of pathogenic organisms. Mixing the mixing influences the distribution of microorganisms, nutrients, substrate, alkalinity, and the release of gas bubbles trapped in the digester content and prevention of sedimentation of the particulate material and even out at a temperature distribution in the digester. In the case of there is inadequate mixing, inhibition can arise due to the accumulation of toxic metabolic by production. So far, there remains no optimum mixing pattern for BMB test. Most full-scale reactors are mixed to some extent to reduce solid retention and release entrained methane. So incubation time. So solid retention time is regarded as the most important parameter for anaerobic digester design and operation. Then SRT accurately define the relationship between the bacterial system and digester operation conditions. Hydrolysis, fermentation, and methanogenesis are directly related to SRT, where an increase or decrease in SRT results in an increase or decrease, SRT, the methane to be generated from a substrate. The longer the SRT, the higher the overall methane production and reduction of biodegradable material. So, when we come to inoculum, the most commonly recommended being the anaerobic digested from wastewater treatment plants due to the full range of diverse and active microorganisms. Part of the standardization of inoculum involves the quality check to indicate whether the operational parameters of the digested are of good quality. So the most common recommendation is to pre-incubate the inoculum for 1 to 5 degrees Celsius at 35 degrees Celsius to degas and reduce the impact of methane. So when we come to substrate, it should be analyzed for all things TS, VS, VFA, TKN. Nutrients, the optimal operation of biogas digester requires balanced concentrations like macronutrients, trace elements, and vitamins for microbial growth support. So reactor is a two-stage anaerobic digestion reactor. So we have made the metabolic conditions. Mixed substrate is prepared and supplied daily in 1 volume of liter to the ACR. Then we have taken 1 liter from the MTR for further analysis. So total HRT is 28 days. Then acidogenic reactor 3 days and MTR methanogenic reactor is 25 days. So pH degrading via AD is a process. That means polyhydroxyalkanates also possible. So while we getting biogas production, the same time we can degrade the microplastics where nothing but polyhydroxyalkanoids wastewater may contain the pH particles or the metabolites. It is important to investigate the effect of anaerobic digestion process application on pH particle degradations. So anaerobic digestion also proper treated particle number, particle size, weight, surface morphology. Also with the application of AD process results in high degradation rate of pH, it could be feasible to apply the anaerobic digestion process for biopolymers based treatment. It is possible to investigate the microbial community of the anaerobic, digester reactor and extract specific cultures which can be applied for bioplastic degrading process. So this is the identification of pH particle analysis. We can identify through these techniques, scanning electron microscopy and Raman spectroscopy. Thank you for listening. Thank you so much.